My name is Ahniyaz. I work for RISE Research Institute of Sweden. I'm a technical project coordinator of the PULSELiON project. PULSELiON project is aimed to develop next generation sulfide-based solid-state batteries. Currently we are wrapping up the lab-scale optimization of the different cell component from the cathode to electrolyte to anode. Next step will be to optimizing those component further at the pouch cell level and start to producing the 1 ampere-hour cell.
My name is Orue Medizabal and I work as a researcher at CAC energiGUNE. CAC energiGUNE leads the BP3 that is could be related to the lab scale process and also interface optimization. And the main aim of these work packages is to produce and also optimize the different cell components within the cell. Also, CAC energiGUNE plays a key role in other different work packages, including the cell assembly and also the testing of 1 ampere-hour cells. I am responsible for coordinating the scientific activity of CAC energiGUNE as well as of the rest of the partners that are involved in the BP3, in PULSELiON project, ensuring alignment across the development, optimization and integration of the cell. The main stakeholders for our organization are battery manufacturers, also automotive companies and also materials developers who are looking for breakthrough solution in solid-state technology.
Hey everyone, I'm Nico working for PULSELiON project and we are in CAC energiGUNE facilities, in particular in front of the glove box where we will carry out the upscaling to pouch cells. And here in this glove box we have all the components and all the instrumentation to do the scaling up, starting from our hot calendering to calender electrodes and the components of the cell. We will then weld the electrodes on our pouch cell, press them to compact it, and then after putting everything inside of a proper coffee bag already preformed, we will seal them to obtain our scaled up pouch cells for the PULSELiON project. Okay, now we have our pouch cell and we are going to the testing lab to test it. We are in the testing facilities of CAC energiGUNE where we actually test the cells in pouch and coin cell format. We have actually around 900 to 1000 channels and we can perform a lot of experiments in different conditions of temperature and humidity and so on. So here is where we test PULSELiON cells in both pouch and coin cell format.
I'm Francisco Ngomo and I'm an innovation consultant in P&O. My role in the project is basically I'm work package leader for the communication, dissemination and exploitation. And inside these work packages, I'm leading the exploitation strategy, which means identifying stakeholders relevant to the project and also help the partners characterize their results and help them brainstorm how these innovations can really enter the market and how can they be beneficial for European society. Exploitation is very important because I think we are seeing it everywhere right now. We have the talent in Europe, we have lots of innovative projects, we have the muscle in terms of economics, in terms of knowledge and in terms of companies. But we are seeing that the real innovation is being led by external actors like the United States or China. And this is why I believe exploitation is very important in European projects, to really see how the innovations that we are working in these projects enters the market and can compete with the external actors and also strengthen European autonomy and economic strength.
What I'm proud of in the PULSELiON project is that one of our partners PULSEDEON is developing a very specific new technology based on the pulse laser deposition, where different components of the solid-state batteries, including lithium metal and electrolyte, as well as protective layer, is deposited directly using this pulse laser deposition technique.
My name is Kekkonen. I work for PULSEDEON in Finland. PULSEDEON is producing the anode and the solid electrolyte layers by pulsed laser deposition technology. We have produced and developed the technology for producing lithium metal anodes in roll-to-roll fashion with pulsed laser deposition technology. We have deposited layers of the solid electrolyte layer and shown its functionality. So we have been able to transfer the materials in such a way that they are functional, and we can produce them as thin layers, controlled thickness, and that way increasing the energy density of the cells and batteries. Nobody else is doing this currently, so we are doing this for the first time and think we are the pioneers. The next challenge is to upscale the processes and really start producing the materials to make cells. As always in upscaling, there are challenges. You need to be sure that you have the correct quality and the quality is preserved for larger areas, for longer production and so on. So everything needs to be sort of perfect.
It turned out to be that the density of the film deposited by pulse layer deposition technique is a little bit low. So our next challenge is to optimizing the density.
Of course, the project KPIs are extremely ambitious. They are challenging, but in any case, how we have calculated, they seem to be achievable. So currently we see no big obstacles in achieving most of the KPIs.
We hope to achieve much better understanding at the interface level between electrode and electrolytes. That I think that is one of the key aspects to have a battery with high performance and reducing defects and cost level. I think that the pulse laser deposition, the main technology used in PULSELiON project, could be very helpful in fostering new possibilities in the battery field, especially in enabling the fact that we can deposit very thin lithium and also argyrodite layers to enhance the specific energy densities of batteries.